Good morning. My name is Prashant. I am an 8th semester CSC student. Today I am going to give a presentation on hybrid computer cluster with high flexibility. It is part of the high performance computing subject. Let's get into it. Introduction. A hybrid computer cluster is a computing system that combines multiple types of computing resources into one unified environment. Instead of relying only on one type of hardware, such as just CPUs or just on premise servers, a hybrid cluster brings closer CPUs, GPUs, cloud machines, and sometimes even edge devices together. So, the very main purpose of this design is to create a system that is both powerful and adaptable. Modern computing workloads like AI, big data, and simulations require different types of resources at different times. So, a hybrid cluster allows organizations to dynamically use the right resources at the right time for the right task. Because of this flexibility, hybrid clusters are becoming essential in research labs, tech companies, and cloud platforms. So now let us look at the background of computer clusters. Firstly, to understand hybrid clusters, we first need to understand traditional computer clusters. A computer cluster is a group of interconnected computers that work together as if they are one system. Each computer in the cluster is called a node and they communicate through high speed networks. Traditional clusters were usually homogeneous, meaning every node had the same hardware and configuration. While this made management easier, it limited flexibility. If a task required GPUs but the cluster only had CPUs, performance would suffer. As computing demand grew more diverse, engineers realized that the clusters need to support different types of hardware. This led to the development of heterogeneous and eventually hybrid clusters that can handle a variety of different workloads very efficiently. Now let us look at what makes a cluster hybrid. Okay, a hybrid cluster is defined by its combination of different computing environments. It may include local servers inside a data center, cloud-based virtual machines, GPU accelerators for machine learning, and specialized hardware for simulations. The system is managed through software that allows workloads to move between different performances and cost requirements. For example, a company might run normal workloads on local servers but shift to heavy processing tasks to the cloud when demand increases. This ability to mix and match computing resources is what makes the system hybrid. The goal is to provide both high performance and high flexibility without being restricted to a single infrastructure. Now, since we've learned about what makes a cluster hybrid, let us learn about the importance of high flexibility. Flexibility is one of the most important features of modern computing systems. Workloads today are unpredictable and are constantly changing. Some tasks require heavy computing for short periods, while others need long term stable processing. A rigid cluster cannot adapt easily to these changes. A hybrid cluster, however, allows dynamic allocation of resources. If an AI model suddenly needs more GPUs, the system can assign them. If the demand drops, resources can be scaled down to save on costs. This flexibility ensures that performance remains high. High flexibility also allows organizations to experiment with new technologies without rebuilding their entire infrastructure. Okay, now that we've learned about the importance of the high flexibility, let us learn how to actually design a hybrid cluster, the architecture of a hybrid cluster. The architecture of a hybrid cluster typically consists of several key components. First, there are computer nodes, which include CPU servers, GPU servers, and sometimes specialized hardware systems like FPGAs. These nodes are connected through a high speed network that allows for fast communication. Next, there is a centralized management system or scheduler that assigns tasks to different nodes based on the requirements. Storage systems are also integrated, often combining local storage with cloud storage for scalability. In many hybrid clusters, container technologies like Docker and orchestration tools like Kubernetes are used to manage workloads. This architecture allows tasks to move seamlessly between different computing environments. Okay, now let us learn about the key features of a hybrid computer cluster. Key features. Hybrid computer clusters offer several important features. One major feature is the heterogeneous computing ability, where different types of hardware work together in a single system. Now, another feature is the scalability. So, scalability means that new nodes or cloud resources can be added dynamically whenever there is a need. So, load balancing ensures that tasks are distributed evenly across the cluster so that no single node becomes overloaded. Fault tolerance is also important. If one node fails, okay, the system can continue running using other nodes. These features make hybrid clusters highly efficient and reliable. Because of this, they are widely used in industries that require performance and adaptability. Now, let us look at the applications of the hybrid computer clusters. Applications. Hybrid computer clusters are used in many fields. In artificial intelligence, they allow training of machine learning models using GPU nodes while data preprocessing runs on CPU nodes. In scientific research, they are used for simulations in weather forecasting, space exploration, and physics experiments. Businesses use hybrid clusters for big data analytics and financial modeling. They are also used in computing environments where companies need to scale resources up and down quickly. Because hybrid clusters can adapt to different workloads, they are suitable for almost any domain that requires high performance computing. Now, let us look at some of the advantages and disadvantages of hybrid computer clusters. Advantages and challenges. Hybrid clusters provide many advantages. They improve performance by using the most suitable hardware for each task. They reduce costs by allowing organizations to use cloud resources only when needed. They are scalable, flexible, and efficient. However, they also come with challenges. Managing a hybrid cluster can be complex because it involves multiple types of hardware and software. Scheduling tasks across different environments require advanced algorithms. Security can also be a concern, especially when integrating cloud resources. Despite these challenges, these benefits often outweigh the difficulties, making hybrid clusters a popular choice. So, now in conclusion, a hybrid computer cluster with high flexibility represents the future of computing infrastructure. By combining different types of hardware and environments, it provides both performance and adaptability. As the workloads continue to grow more complex, systems must be able to scale and adjust quickly. Hybrid clusters meet this need by allowing dynamic resource allocation and efficient workload management. So it provides both performance and adaptability. They are already widely used in artificial intelligence, big data, analytics, and scientific research, and their importance will only increase in the future. Understanding hybrid clusters is essential for anyone working in modern computing and distributed systems. Thank you.